Once again, I'd like to introduce Serge Boulanger, a partner of our LDV Vision Summit since we started 10 years ago, and one of our LDV experts, to intro our next speaker.
It's now my pleasure to introduce the next speaker, Stefan from SandboxAQ. Stefan is the Vice President of Engineering and Lead Scientist at SandboxAQ, an enterprise SaaS company providing solutions at the nexus of AI and quantum technology to address some of the world's most challenging problems. The company's core team and inspiration originated at Alphabet Incorporated. As the inaugural member of the Sandbox team at Alphabet, Stefan played a pivotal role in transforming theoretical concepts into tangible, real-world applications.
All right, thanks everyone. So today I'm going to talk a little bit about, AI, of course, is very important in everything that everybody does, but I'm going to add a bit of quantum technologies into it. That's what the Q stands for in SandboxAQ. And I think, some of the themes that I want you to, take away, I'll say up front. One of the themes is that when I say quantum technologies, I'm not talking about some far future thing. I'm talking about things that can be used today for, capabilities that we can use today and products that we can build today. And for that reason, I'm also not going to really be talking about quantum computing. Quantum computing gets a lot of the hype within quantum technologies, but really the focus of this talk is going to be more around quantum sensing, right? Which, in the theme of, visual technologies, it's around being able to use quantum technologies to see our world in new and exciting ways with unprecedented levels of accuracy and precision and unlocking a lot of new things. So a bit about the motivation here. This is, again, the theme behind everything that we do at SandboxAQ. It's really about connecting this sort of physical world through, for example, new modes of sensing with the world of bits, and that's where the AI comes in. And it's really these things have to work together in order to really make progress. The triple sort of the triple whammy of technologies here is AI, sensing, and simulation. Okay, so sensing, as I mentioned, is using new kinds of devices, which I'll talk about in a minute, in order to take in information about the world. Use AI in order to understand and process that information so that we can make sense of it. And then finally, simulation, because, of course, in order to, understand what we're doing, especially if we want to use AI, we need to have a lot of examples, right? But the physical world, the data that we get directly from the physical world is kind of limited. We only have so much of it, but we can use simulation to synthesize new kinds of data to figure out what's going on, which we should expect to see from our sensors and combine it all together. Okay, so a little bit about the sensors, a little bit about the technology, and then I'll talk about some applications. There are many different kinds of quantum sensors, but I want to focus on some of the kind that are available today. So one example is what's called an optically pumped magnetometer, or OPM. The idea here, and you can make these out of different kinds of materials, for example, cesium, as I have written here. The idea is kind of simple from a quantum mechanics point of view, but you have a gas of atoms. You shine like a laser on it in order to polarize these atoms. And then based on the magnetic field, the ambient magnetic field that these atoms are sitting in, they will precess, or their spin of the atoms will move around in certain ways and will affect, for example, the transparency with respect to another laser that's coming in. And this kind of idea of precession of spin and using that and the ambient magnetic fields, it's the same kind of principle behind an MRI. And an MRI is an old technology. What's different now? Well, an MRI is big, expensive, has to be super cooled in order to work, is the size of a room. And the technologies we have today, the difference is they can be room temperature, they can be small, they can fit in your hand or even smaller, and unlock a lot of different kinds of applications. One kind of application, for example, kind of similar to an MRI, you can think about new medical devices. If we're looking at very tiny, like picotesla magnetic field changes, that's enough to pick up what's the magnetic field created by your heart as your heart is beating. It's, the currents are making magnetic fields. And these things are known, these kinds of magnetic fields are known to be medically useful and can diagnose heart disease. Again, we have to, in order to process this data, it's very noisy. We have to take it, process it using AI and simulation, and then create new kinds of medical diagnostic techniques. And these things are, being built right now, being tested, and it's a very exciting time. Just quickly mention another application of the same kind of thing. If you're looking at tiny magnetic fields, take a look at the magnetic field generated by the Earth. It's not just pointing north, it's changing bit by bit as you move around. And as you're moving around from place to place, you can use it to tell where you are. You can have a map of this changing magnetic field as you move around and use it to correct your drift. You may see in the news, if you haven't yet, take a look. The GPS is not very reliable these days. It's getting blocked all the time and blocked and spoofed. And so it's a very exciting time for these kinds of technologies, and there'll be many more to come. So thanks for having me.